Next speaker, we have Mr. Tejbir Singh, Associate Sales Director, ABB India Private Limited. And he is also a very vast experienced person. He has 30 years of experience in analytical and automation solutions. Again, the automation is very important. We cannot rely on the personal or human interference every time in any kind of the measurements. So automation solutions, what he can provide and what the companies are providing, maybe we'll have to hear from his speeches and the presentation that he's going to offer. And he's currently the Associated Sales Director in ABB India Private Limited. And he's focusing mainly on business development, creating new energy markets in Delhi and NCR regions. And he has a very good leadership background in engineering, project management, and sales, along with global training in advanced analyzer technologies.
Let me take this opportunity to thank the organizers for this presentation. Delegates, my name is Tejbir Singh. I come from ABB. Today I'm going to talk slightly different. Spent many years in the emission side, in capacity building. Mr. Kemotra, Mr. Pathak, great respect for them. There's a lot more happening in that space than just the stack emissions or the effluents. So I'm going to talk about the current practices and the advanced leak detection solution in fugitive emissions in CGDs and natural gas pipelines. Why is it important? We'll look into that. So I'm going to be very quick on the introduction part, context and key drivers, advanced leak detection system, and summary. I have a video also in the end, we'll show you that. So ABB has been innovating with technologies for the last 130 years. We are into many businesses from electrification, process automation, motion, robotics, and so on. On the analyzers, we are basically enabling process plants from safety and production efficiencies, also certifications and compliances to the emission and regulatory compliances, greenhouse gas climate change monitoring. In terms of the product portfolio of analyzers, we have a very widespread. We are the #1 player in the world in terms of the technologies installed base and the support we do extend across the world. From continuous gas analyzers, typically emission systems, process analyzers, chromatographs, FTIR spectroscopy. Every refinery today, I see a lot of oil and gas industry or any refinery would go with a FTIR blending solution for fingerprinting your fuels which you produce. Water analyzers, and a very new analyzer on the block is the advanced laser spectroscopy. That's the subject I'm going to adapt today. So there is a common saying, a product is as good as its backup services. No longer that is the limit. We have now a lot of digital solutions come in. We are invested very heavily into coming out with very user-friendly. So let's look at customer support. Today you could take a smartphone, go to our analyzer device, look at the dynamic QR code, take a snap, send it to us, and you would have a real-time diagnostic data of what the fault is. So when you're struggling with skills at the local end, this is a very smart way of picking up the real diagnostic issues instead of making multiple calls and sorting it out. You could dial into the equipment and do the diagnostics. There's a measurement assistant which uses generic AI in the background. You have a problem, just type it there, it gets you the solution from all our expert manuals which are existent there. So you don't have to make multiple calls. So that's one step in customer service and so. Go on to data-driven solutions. We have talked about emissions. There is also a terminology called PEMS, not like SEMS, predictive emission monitoring. We also do that. So it should be part of the regulation. A lot of countries have this where you do not have to install a device, but using softwares, neural networks, you can predict what's the emission data going to be. So that's part of our data-driven solutions. We also have the leak detection I'm going to talk to you about, part of the digital solution. And moving forward from a reactive to a preventive to a predictive mode. This is where the world is moving. This is where the solutions we bring to you there. We are headquartered in Bangalore. We build our assembly lines for sensors, pressure, temperature, instrumentation. We also do the analytical assembly line, typically very custom designed. Let's take it, emission system in a cement plant or a steel plant is totally different than what would be in a refinery or a petrochemical stacks. So we do across there, extremely customized. We build process analyzers, liquid analyzer systems, walk-through shelters for refineries, typically petrochemical complexes and fertilizers as well, and walk-through water analyzers. So those are the solutions which are there. On to the key drivers and the context. These are extremely important because that's how you decide where to put your money in and how to stay sustainable in the marketplace. We've heard a lot about the Kyoto Protocol, Minamata Commissions. I think enough has been spoken today, and very rightly, I would say very good context happened in the first half. These are all driving international regulatories. For example, the EU norms adopted by many countries, US EPA norms. CPCB has come out with a guideline based on those. A lot of changes have happened, like leapfrogging into the BS6, for example, cleaner fuels. And right now we are going through a cusp of energy transitions, all towards net zero, cleaner fuels, reducing our carbon footprint and so on. I would like to bring you another very interesting aspect of what we do with our optical sensors. Not too many of us know about it, that we are also make optical sensors for space. Today, we work with all the leading space agencies with our optical sensors. So a satellite moving up is probably looking down onto your asset and able to pick up as to how much methane you are releasing or how many other gases you are releasing. Besides the known NASA, SpaceX, European, Japanese, so on, there are a lot of private satellites which are releasing targeted satellites for methane detection. Now, why would that be? I think the climate scientists have figured out the methane is a bigger culprit than just CO2 and has a much longer impact on the the heating in the climate change. So we do both from space as well as at the earth level. We do the leak detection. I'm going to talk about those methane detections. So basically a satellite is able to quantify the leak, look at the fingerprinting where exactly it has happened, and fundamentally, we have to be very honest in what we are reporting. There are no borders, no boundaries, and basically no place to hide. So on to the problem statement on the city gas networks. I think besides the revenue loss of leaking gas, I think the key focused area which I find from all users is the safety and the risk avoidance. And there are a lot of reasons behind it. I think very typical things besides the conventional aging process and the bad PR associated with an explosion or a casualty and so on. I think there are multiple agencies also involved. Let's look at in Delhi. There are so many agencies digging up the ground level. Some optical fiber is going, some municipal guys. It's very difficult to coordinate among agencies. And these are also contributing in a very big way on the methane leaks. Efficiency, from a conventional way of measuring to more fast and efficient way, and the environment compliances for climate change. Right now, we have a very slow process of a handheld device to go and look at for leakages, typically methane. And when you look at this methane in a process pipeline, you have a higher concentration. Close to it, you still have in ppm levels. As you go beyond, your concentration of methane goes down to parts per billion levels, if not ppt levels. So these are some challenges from a very manual-oriented approach to a very automated approach. Now, these solutions are very adaptable depending on what the applications are. If you are a particular asset, then you could do something with sensors, multiple there. If you are on a vertical building or a trunk pipeline, you would require a drone or airborne solution for it. And for a handheld inspection, like a pinpointing, then you have a handheld device to do it. So the current situation is we're doing the walk the line. That means you walk the pipeline to look for leakages. This is very slow, very expensive, very labor intensive to do. And these are some of the devices I put, which you see on the side, which are the handheld devices currently being used. They are not as sensitive because they look at ppm levels and more and cannot go down in the ambient much lower. If you look at the total capacity of consumption in city gas, we have about 35 million cubic per day is the consumption. Calculation wise, you're looking at, even if you take a nominal 2% leak, you are looking at a 1.6 CR or loss per day. In an annual basis, it's about 580. Even if you half this percentage to 1% also, it's a huge number. And besides the losses, we are looking at an environment impact which is not reversible in many ways. So we have got into a very mobile platform of measuring. You can drive at a much faster pace, cover a larger distance, and completely automated reports out of it. We'll discuss that in later. On to the technology, the off-axis integrated cavity output spectroscopy. This is a very advanced laser technique. In fact, this is a general perception in the market that the laser is going to replace many technologies because it's very precise, hardly any maintenance, and it can go down to very low sensitivity levels as well. I don't believe it's going to replace everything, but it is doing in lot applications. So on to the technology. This got acquired by ABB in 2013, a company called LGR, Laos Gatos Research in the US. It has a patented technique of measuring using the optical spectroscopy. So in any optics, Lambert-Beer's law is the fundamentals. Lower the concentration, larger the path length you require to have a sensitivity of measurement. So this particular technique is very simple. Just in a vacuum chamber, you have very reflective mirrors. We're able to convert optical laser up to 25 kilometers path length and go down to parts per billion or parts per trillion level of sensitivity. So a lot of applications like hydrogen cyanide, for example, I personally felt after all these years that they were not possible to measure because signal to noise ratios and other drift rates, background interferences are today possible. So this is in a very simple way without making it very complex. This technique is very versatile. It is adopted in climate change for decades now, and we have adopted that technique into the industry. So many cutting-edge institutes like ISRO, CISR labs, IITs are using it for climate monitoring, like greenhouse gases, like typically methane, CO2, nitrous oxide, even carbon isotopes, nitrous isotopes. In hydrogen research or glacial research, you use triple isotope, water isotopes to monitor. So there's a lot of study going on. The world has already been doing it for years. We are also doing it here in India, and we are very much a part of it. This technology is now adopted by many licensing companies in the refinery petrochemical side, and very well established there. On to the detection solutions, we have 3 platforms. One is the mobile guard, which is the driving, you can drive with that solution. Handheld one or a backpack one is the micro guard, and the drone based called hover guard. So on to the mobile guard, this is typically for an urban setting where you may not be feasible to run a drone and you could drive it around. So what is it based on? We've seen that the analyzer is extremely sensitive. It goes to ppb levels. Along with that, we're using data analytics, which is picking up data of anemometer, which is the wind velocity and the wind direction. Pick up the GNS, the Google, the location from satellites, and the sucking the gas from the atmosphere. All these 3s are able to go down to 1 ppb levels of methane, 2 ppb levels of ethane. Now you would wonder why ethane? It is because generally in the urban settings, you have a lot of methane floating around. We have done pilot studies here. Every sewer line, every drain is releasing methane, and you wouldn't know where the methane is coming from. So the ethane is a fingerprinting for natural gas, unlike a biogas which is coming in. So we're very clearly able to identify what gas are we measuring out of methane. So while we are using data analytics, while the drive, you can get all your alarms, you can see, you can plan your drives, you can also look into areas where you find more likelihood of leakages and problem areas. And everything is instantaneous. So you get your reports in digital format, you get a print reports, you also get SCADA files. So if you have a SCADA network of pipelines you don't want to share with us, you could superimpose the KMZ files and KML files or shape files in your SCADA and know exactly where the pipeline, the leakages are taking place. On the drone-based solutions, this also uses the same concept of data capture. It's a miniaturized version of 3 kgs only. Smaller drones can fly it. You could plan your routes. You could get a heat map from where the leakages are happening, and then you could pinpoint it using a handheld device, which could move on to the site to know where the locations are happening. The handheld device also measures methane, ethane, so we know we are on the same platform. This data, as you can see, is going into your SCADA network or command center, where you can take a quick reaction team and then also decide what to go about it. I have a small video to run, and this is how I will just conclude it. Audio, please. I'm sorry, there's no audio. So let me chip in there. So you can see a car driving around. Most of your polymer pipelines are underground, and when the leakage happens, they don't necessarily come out in the vertical direction. They get diffused to cracks and come out. So you can see the red. You're not able to see it. I'm so sorry. Okay. Okay, thank you. Thank you, and I have just a few slides of some of the projects which milestones have been done. Just want to share those. Just 1 minute. This is the global footprint of how these technology has been adopted across the globe, from the Americas to Europe to Japan. In fact, this year the Japanese Prime Minister awarded the team which implemented this solution. And so basically the methane pledge is the driver as per the regulations to mitigate. 100 countries have signed up. So this is where it fits in. This is a pilot study we did with 3 gas companies, IGL, Thingas and Gale Gas. You can see 23 emissions were detected, out of which 9 were biogas related. If you had a handheld device, you would never know. You would just be digging up or looking at what. So the unseen is what is getting captured right now here. A lot has been talked about the emission side. I think in the transition, a lot of fuels have been also looked at in terms of the combustion. If you look at municipal solid waste is one area which is being looked in incineration for waste to energy. Typically, conventional gases or SOx, NOx, you have now HCl, HF, TOC, ammonia all coming out. Not easy to measure with conventional technologies. I would like to share NTPC team, I'm not sure whether they're here or not, but a project which we implemented with NTPC in Varanasi, a flagship, the first project of municipal waste into green charcoal. NTPC spent a lot of time to understand how it worked, and the waste to energy, they took the EU guidelines where the best available technique of FTR spectroscopy. So 10 gases are being measured simultaneously in the stack.
Tejbir, we have limited.
Okay, I'll just wind up. So hydrogen
crossed
cyanide, I just want to cover this. We have done this in IOCL Panipat for Lanzertech, which is measuring the refinery off gas, capturing it into biodigesters, and this process is measuring all trace level impurities. So this is my last slide. Many projects, including the coal gasification and the carbon capture project. Thank you very much. Sorry for the extra time.
Thank you very much. Just like an apple a day keeps the doctor away, adopting the new technologies and innovative technologies by industries, MSMEs and various people can keep the regulators away. So I'm sorry for this, but yes, of course, we need to adopt new technologies, innovative technologies. We have to see the future of emissions, how to control these emissions. So